For as long as most of us can remember, black holes have been seen as one of the scariest things mankind has ever come across. They have the ability to swallow up anything that comes too close, including galaxies, stars, and any other matter in their reach. But there is much more to black holes than meets the eye. The thing is, you can't exactly get up close to one to study it, or can you? Well, scientists have just admitted that they've created an actual black hole in their lab, and well, it's revealed details that no one saw coming. Join us as we explore the incredible and mysterious world of black holes, what scientists were able to find out with the one they made, and what it all might mean for the future of science and mankind as a whole. Black holes are truly a mesmerizing phenomenon with an almost supernatural power. They captivate scientists and the public alike. But what exactly are black holes? To start, let's look at Einstein's theory of relativity. According to this theory, space and time are intertwined in what is known as the fourth dimension. This means that gravity isn't a force as we might think, but rather a curvature in spacetime caused by mass. If we were to visualize this concept, it would look like the surface of a trampoline with a bowling ball placed on it. The ball causes the surface to sag, pulling smaller objects into the dip. Black holes work in the same way, but they have an infinite density, creating an abyss in spacetime that is nearly impossible to fathom. The mystery behind black holes began with the English natural philosopher John Michell in 1783, who first suggested their existence. He theorized that despite being invisible, these intense gravity fields might be detected if they had a star orbiting them. This prediction was confirmed in the early 1970s when astronomers Louise Webster, Paul Murden, and Thomas Bolton observed an invisible object orbiting a blue star from 6,000 light-years away. The object was codenamed Cygnus X-1 and is regarded as the first black hole to be identified. Not only do we know that there are potentially as many as 400 million of them in our own Milky Way, but also that at least 2 trillion galaxies in the observable universe have supermassive black holes at their center. This means that areas of space containing multiple galaxies can contain hundreds or even thousands of supermassive black holes. These mysterious objects don't just suck in matter and energy, they can also emit radiation from the edge of their event horizon. This is known as Hawking radiation, after Stephen Hawking, who predicted its existence in 1974. But it was just that, a theory. There wasn't really any evidence that could support anything related to it. You see, black holes are everywhere in our universe, yet they remain shrouded in mystery. It's incredible to think about how much power must be contained within them. Although we may never be able to truly understand black holes, they provide us with an opportunity to study the unknown and discover what lies beyond our universe. For centuries, scientists have worked tirelessly to unlock the secrets of these fascinating cosmic objects and make sense of their immense power. For now, all that remains is a sense of awe and wonder. With the ever-growing knowledge base around black holes, who knows what other secrets remain to be uncovered? The possibilities are truly limitless. But the problem of no one actually being able to get close to one still stands. How do you study something you can't get a good look at? Here you might ask why. Why can't someone actually go inside a black hole to gather information? What would happen if anyone got too close? To answer this question, we must first understand what happens in the immediate vicinity of a black hole. A black hole is surrounded by an event horizon, a region at the edge of the black hole where light cannot escape. If you were to get too close to a black hole, you would cross this event horizon and plummet toward the core, which is known as the singularity. As you approach the event horizon, time slows down a lot compared to what an observer far away from the black hole would see. This means that the closer you get, the slower time would appear to be passing by. Approaching the event horizon, the most powerful gravitational forces in the universe come into play, and they'll affect everything. This means that as you continue your descent into the black hole, everything around you will become more and more distorted until it eventually reaches a point where it is unrecognizable. It is thought that at this point, the intense gravity would start tearing apart any matter in its path, stretching and crushing it until it reaches a state of total disintegration. Even if you were able to survive the journey, which is unlikely, eventually you will reach the singularity, a region where space-time itself collapses and nothing can escape. As you cross the event horizon and plunge into the depths of a black hole, light from distant galaxies will pour in through the one-way window. From this perspective, it is almost as if you are able to observe the evolution of the universe over billions of years all at once. Although there would be no way to stop your descent into the black hole, you can experience a unique view of the universe beyond. Crossing this threshold, you will be ripped and distorted by the intense gravitational forces until you are eventually broken into pieces and scattered across the singularity. All that would remain is an empty space, a stark reminder of the power of a black hole. The journey towards a black hole is one that no human has ever been through, but the thought of what would happen if you were to cross the event horizon provides an intriguing glimpse into a world beyond our own, a place where time and space are twisted and distorted in ways we can only imagine. The mystery is one that has captivated scientists for centuries, and it is only through continued exploration of the unknown that we will ever be able to fully comprehend this strange phenomenon. That's exactly where the lab-grown black hole comes in. In a groundbreaking experiment, scientists have succeeded in replicating conditions that mimic the formation of a black hole in their lab. By creating a one-dimensional chain of atoms and allowing electrons to skip from one position to the other, they created an event horizon, which interferes with the wave-like nature of electrons. This produces a rise in temperature, as theoretically expected of a black hole. It's the common concept of the higher the power, the hotter things get. The experiment simulates the natural process that has been hypothesized to have taken place in the early moments of our universe's formation. Particles are created by disturbances in quantum fluctuations caused by a black hole's tearing of space-time. In essence, these disturbances act like tiny ripples on a pond, spreading out from the center of the black hole and making their way outward. Things like this aren't simple. The scientists conducted their experiment in two parts. First, they suspended a series of rubidium atoms in an ultra-cold cloud to create a one-dimensional chain that very closely resembled the structure of a black hole horizon. They then allowed electrons to jump between the atoms, thereby producing a black hole-like temperature. In the second part of their experiment, the scientists then used a laser to simulate the balance in quantum fluctuations that would be created by a black hole's gravitational force. This generated a stream of particles known as Hawking radiation, which gave off visible light and could be detected via imaging techniques. The experiment, which was conducted using techniques that are now commonplace in quantum physics experiments, proves the possibility of recreating a black hole in the lab. While the scope and scale of the simulated event is much smaller than what happens naturally in space, it nonetheless provides an important insight into how matter moves and behaves around a black hole. The findings of the experiment have far-reaching implications for our understanding of physics, cosmology, and astronomy. Perhaps most significant is that it provides a potential way to test theories about how matter behaves around black holes, something which has until now been impossible due to the huge scale of such phenomena, the threat to human life, and the sheer force a black hole brings to the table. Similarly, understanding the behavior of particles created by Hawking radiation could reveal more about the nature of dark energy, which is thought to play a major role in the evolution of our universe. In short, this experiment has achieved something remarkable. It has allowed scientists to take one small step toward understanding the mysteries of black holes and the universe itself. It's a huge leap forward in our knowledge, and we can expect many exciting discoveries in the years to come. The ability to create a black hole artificially has offered scientists the opportunity to observe and study these objects up close. By engineering a black hole in a lab setting, we could watch it evolve and gain valuable insight into how matter is transformed under extreme conditions. This could potentially revolutionize our understanding of the physical laws that govern our universe. Not only would it enable us to study these exotic objects in a safe environment, but creating a black hole also gives us access to one of the most powerful forms of energy known to man, Hawking radiation. This is released by black holes and could be harnessed as an incredible source of renewable energy. It has been estimated that the amount of energy released by a 1 kilogram black hole could be equivalent to more than 10,000 times the total electricity consumption of the United States in a year. The potential for scientific advancement here is truly mind-blowing. Being able to observe and analyze how matter behaves under extreme forces would enable us to learn more about the physical laws of our universe. This knowledge could help us to determine whether or not time travel is possible, discover new sources of clean energy, and make advancements in fields such as quantum computing. Furthermore, creating a black hole would provide us with an unprecedented opportunity to probe the mysterious depths of our universe and develop effective strategies for detecting and deflecting potential cosmic threats such as asteroids or comets. This could potentially help protect humanity from any potential extinction-level events in the future. To sum it all up, creating a black hole would open up unprecedented possibilities for scientific advancement and exploration. It would enable us to observe and analyze these mysterious objects up close, harness Hawking radiation as a renewable energy source, and research the depths of our universe in order to detect any potential cosmic threats. In a way, you could say that a black hole might just be the Pandora's box we need to get the Earth back to functioning in a way that's not harmful to it. But at the same time, knowing how dangerous a black hole can be, should we really be taking the risk? Let us know what you think in the comments below. If you liked this video, please give it a quick thumbs up, and we'll see you in the next one.